Pages 41 and 42 in your lecture tutorial book talk about hotspot volcanoes. Now this is going to be a little bit of a review because we talked about hotspots earlier in the semester when we talked about plate tectonics. However, some students are still a bit confused on how to know what direction the plate's moving or why the ages change in a certain direction along hotspot chains. So this will be a good review. It'll also be a good preparation for the next lecture tutorial video that I have, which shows you a different way that you can get a chain of volcanoes other than a hotspot. But let's focus on hotspots in this one. The learning objectives are to interpret the movement of the tectonic plates based on the ages of the volcanoes and to predict the location of active lava flows in a hotspot chain. This diagram here shows 4 volcanic islands formed from a stationary hotspot, and the age is listed in millions of years. Island A is 0 to 1 million years of age, Island B is 1 to 2 million years, C is 2 to 3 million years old, and D is 3 to 4 million years old. So that's the age of the volcanic material that makes up those islands. The first question is, where is the hotspot now? It must be at this end because A is the active island. Its volcanic age spans from 1 million years ago to 0, which is the present. So that must be where the hotspot is now. And as such, that's the location that has active volcanoes. B, C, and D no longer have active volcanoes. The next question asks which of these 2 arrows best shows the direction of the plate that's moving over this stationary hotspot. Now, before I give you the answer on this, let's think about the next question and these 2 students who are discussing the 2 options. Student 1 says that the hotspot does not move, and so the plate moves over it in the direction of arrow A. So the idea would be that the hotspot might be over here, and B has moved off of it, and C and D have all moved off of it to the right. Student 2 says, no, the hotspot's moving from island to island, so I choose arrow B. So that means that here the hotspot was erupting 3 to 4 million years ago, and then 2 to 3 million years ago, then 1 to 2, and then the present. So this student says that things are moving to the left like B. But the key is that hotspots are created by stationary mantle plumes. So the hotspot is not moving, and student 1 is correct. The direction of the plate is the direction shown in A. So here's that arrow showing the direction that the plate is moving. And now to answer question 5, I'm going to do the following. I'm going to put my cursor over here, and this represents the plume. When I click, the whole page is going to move in the direction of the arrow, but my mantle plume is going to stay here, again, represented by my cursor. So let's go ahead and do that. Here's my cursor. My cursor has not moved, but the page has moved, or the plate. And so the next island is going to be to the left of A. That's the answer to number 5. This is where the next island will be. Now we're going to apply this to the real set of islands in Hawaii. Hawaii is a chain of islands formed by a hotspot. And on this map here, they are showing the hotspot location, mantle plume, at the star. So which island is made up of the youngest rock? Well, it must be the big island because this is where the hotspot is closest. These are older. The next question asks which way the plate is moving. And A and B are your choices. So before we answer that, let's remember a cartoon that's from your textbook. I showed you in the video Rocks 7.1. And this is showing a side view of Hawaii. Here's Hawaii, the big island, Maui, Oahu, Kauai, and they have a few more here. And so that's showing the islands in this direction. And here's the mantle plume that is currently feeding the big island. You can see that because the mantle plume is stationary, the plate must be moving to the northwest to have created these islands as it does. And the newest island that's being created is Loihi, which is still underwater. This means that A is the correct answer for number 7. 2 students are discussing where they would want to go for vacation. One student says they want to take hikes in tropical areas and see lava flowing, so they want to go to the big island of Hawaii. A second student says that they've heard great things about hikes in Maui, and they also want to see some lava flowing. So which student do you agree with and why? We know that the last time Maui had erupting volcanoes was 1.3 million years ago. So student 1 made the best choice if they want to see lava flows. There's not going to be any lava flows in Maui or any other island in this direction. You have a friend who moves to Kauai. Should they get volcano insurance? Explain why or why not using information about hotspots and tectonic plate motion. Here's Kauai over here. And Kauai is no longer near the mantle plume. It's been moving away from the mantle plume. The last time it had active volcanism was about 5 million years ago. So Kauai is pretty safe from any volcanic eruptions.